Okay, so writing the question down for 15, the first thing that I notice is there's only two terms here, so I suspect this might end up being like the difference of two squares. However, this has some a's and some x's, and this has some a's and some x's, so the first thing we need to do is pull out a GCF. They both have at least one a, and they both have at least one x. So factoring out a GCF is like undistributing. So I got to think about, if I distributed this to the first part, it needs to give me all of that. So I still need an x squared. And if I distribute it to the second part, it needs to give me that. So an a squared. And now it is factored. It's not factored completely though. GCF is usually or often just the first step. Makes the question a little bit easier to see, but now I can see there's something being squared on the left, something being squared on the right, and the difference of two squares always factors as a plus and a minus. So if you know that pattern, you can do it very quickly. If you choose not to memorize that pattern, you're going to have to call this like, you'd have to squeeze in 0 AX's and then factor this trinomial to get the same thing. That's a lot more work, so definitely nice to know the difference of two squares.